This is Jan, and I will show you now how we can denoise a tree. So this is a point cloud which I loaded. I prepared already because it's quite computational heavy. So you don't see much, and we have a lot of needle hits on top of our branches. We will try to get rid of this noise. And what I did, I have two filters. Denoised by Belton et al. You can you need to give the loaded point cloud as input, and you should read this publication. It's a really good publication and it explains a lot. There is a second step, SimpleTree denoising routine, which is kind of based, the idea is kind of based on Belton et al. But it has no peer-reviewed citation. It will subdivide your cloud into 10 subclouds, or 5 if you make it 5 here, and you give a range 5 centimeters I give here. This is a range in which you analyze changes of curvature. So around the point, this one we look 5 centimeters and look how the curvature changes. And based on this information, the cloud will be subdivided into 10 clusters. So it is already computed. It's quite a long computation time. The computation time gets faster the more you the larger you make the radius. So this is a good cluster. I can see here we have branches included, but the stem was missing. This is a shitty cluster, we don't want it. Or sometimes you have to be really careful. This cluster we need 1, 3. This is not sure. This we shouldn't need. This is also not the best. Here we might lose these points if we don't use this cluster. Definitely noise. The majority of the cloud is noise, as we could see before. And this cluster I will use. So it is 1, 3 were good. So I put here on top merges multiple clouds. 1, 3, 4, and 10. I cannot bring it back to the screen. Wait, I make a trick. I don't know what happened now. The visualizer doesn't work. So points, export points, XYB, the merged cloud. The data test pine normally this saving shouldn't be needed. I load the data test pine. So hopefully I can bring it back to the screen. Yeah, this time we have it. If you think this is not properly denoised, let's see what a little bit more clustering does for us, because we got rid of already the majority of noise points. And now points clusterize, filter, Euclidean clustering, denoising. I love this filter. So let's say we want to keep the 3 largest cluster for now. It's a manual method. This one you will never be able to set in a pipeline. That's why it's not included. Of course, it would be beneficial to have efficient leaf denoising in an automatic pipeline, but it's not. We don't have it yet. And now this already looks a lot better, right? So this tree could be better modeled, and of course, if I would set the number of parameters to 1, then this should be away. The ground fragment should be gone, and maybe part of this. So I recompute. Okay, so now, because the point cloud wasn't really good denoised, we could also do a trick here with these buttons, learn how to use them. We could, Alexandre needs to tell a bit. So I want to select points now, and I want to remove selections. You can manually segment the stuff of the other tree out. I mean, invest more, please. But So this looks better. You can do it on this side too. And if we now only the red points would be saved. If we would go to base exporter points XYB, and then it would be only the red point saved. This shouldn't be needed in case you work with my segmentation routine. It is a cloud which I produced with an old version of the software, and well, you need to get rid of this artifact too. But that's it. Belton et al. Work similar. It always produces 10 clusters, and you should really read the publication, read both of them. Like, they are hugely beneficial. Bye bye.